Okay, packet 9. Packet 9 is dealing with sequences, okay? And we have dealt with sequences, okay? So I'm just going to start out with a few notes. So let's write these down. We're going to start out with a few notes, okay? And then I'm going to go over some of the questions. So sequences, here we go. We have arithmetic sequences. Okay, and that's not spelled right. I think that E doesn't belong there. Okay, so at this moment I can't spell arithmetic, but okay, let's pretend like I can. And this means I have a common difference. Okay, arithmetic common difference. Okay, this is subtraction. Second term minus the first term. Okay? And because it's a sequence, that means that whatever I find to be that common difference happens every single time. If I take term 3 and I subtract my common difference, I should get term 4. Okay? Once I find that common difference, I shouldn't say subtract, sometimes it's adding. Okay? But whatever that difference is, it should get me to that next term every time. So, arithmetic common difference. Second term minus the first term is going to give me that. Okay? Now, the other one is geometric. The geometric sequences have a common ratio. Okay? I'll give you a moment to get that written down. A common ratio is the second term divided by the first term. Okay? So this is how we find the ratio. And then once we have found the ratio, we then multiply to get the next numbers. Okay? So just as a reminder there, I divide to get that ratio, but I'm multiplying to get the subsequent numbers in the sequence. Okay. So that's just some beginning. Okay. And then one other little piece of information. Remember that N are the terms. N means terms, and for us that means like those are the counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Our counting numbers. When you see N, that's terms or our counting numbers. And A sub 1 is the first term. Okay? A sub 2 is the second term, A sub right. Okay, just as a reminder. Yes, James. That is correct. And if you're not sure, like if you're working on a problem, you're looking at that sequence and you're not sure if it's geometric or arithmetic, what I always do is check arithmetic first, because to me that's easier. So if you're looking at numbers you don't just immediately recognize, okay, I'm going to check and see, can I add or subtract the same number every single time? If I can't, then I'm going geometric. Excellent question, James. Thank you. Okay, here we go. So let's look at problem number 1 now. Consider the geometric sequence. It's geometric, so I know I have a common ratio. So little r, okay? We're not writing that word every single time. So I've got a common ratio. Here is my sequence. I've got 6, 24, 96, and 384. Now I can look at those numbers, and this is what James had asked is, if I multiply, that means it's geometric, and if I add every time, it's arithmetic. That is exactly it. And you can look at these and tell, are you going to add a number to 6 to get 24 and add that very same number to get from 24 to 96? Well, you know that's not possible, okay? So I know this is going to be a common ratio. And what is the common ratio? Well, it is the second term divided by the first term. 24 divided by 6, and that's going to equal what? So that is my common ratio. Now listen to these directions. What is the sum? So I'm going to need to find the sum. That's an important word there, so you need to write that. Sum of the first 9 terms. The first, can't spell first either, 9 terms. In order to find the sum, I've got to find the first 9 terms. So here I go. I'm going to make my table. Here are my terms, and I need 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? I'm going to make sure I get them all. Okay? And these are my f of n, or a's, right? Okay? A sub n. Now, I already know 1, 2, 3, 4. My fourth term is 384. I already know that, because 6, 24, 96, 384, I've got to find those first 9 terms. What am I going to do to 384 to get the 5th term? Multiply it. Okay? So then we should get 15, 36. I need y'all to double check me here. Okay, if I get it wrong, please let me know. And then when I take that and I say times 4, I should get 6,144. Okay. Then when I multiply that to 4, I should get 24,576. Thank you, Preston. I appreciate it. And then when I multiply that to 4, I should get 98,304. And then I multiply 4 to that one, and I should get 393,216. Okay, give you a second to get those written down. But now what I need you to do is find the sum of those. What does that mean we're going to do? Add them. So I'm going to add that column of numbers. So there are two pieces to this. First of all, I got to find all 9 terms, right? And actually, I just have to find 5 through 9. Then I have to add them together. And when you do that, you should get 524,286. And that is your answer. So make sure you're reading the directions. It may have more than one part. Okay? Okay, questions about that? And I added to get the sum, means you add. Okay? All right, number 2 says, a recursive sequence is defined as A sub 1 equals 2. What does A sub 1 mean? First term. Then A sub n plus 1 equals negative 3 times A sub n. Okay? Remember, this right here, just got my previous, this is my previous term, this is my answer. Okay. Which sequence follows from this recursive definition of a function? So, look at the answer choices. A. So A says this: 2, negative 6, 18, negative 54, 162, and they have to have the ellipses, the 3 dots at the end, because it continues. How am I going to check this? Well, I'm going to tell you how I'm going to check it, because it's easier for me. I'm just going to make a table, counting numbers, and my A sub n. 1, 2, 3, 4. 1, 2, 3, 4. That should be enough to be able to tell if this works. So what I'm doing is I'm checking to see if this works. I'm using this right here. But remember, a recursive rule has to tell me, what is A sub 1? What's A sub 1? What's the first term? 2. It says it's 2. So my first term is 2. So I'm already on the right track with choice A, right? So it can't be C or D because it doesn't start with A sub 1 being 2. My first term is 2. So it's either going to be A or B. So let me check. So if my first term is 2, I'm going to go here and go, how do I get the second term? Well, I take what it's given me times the previous term. Okay, remember that? So what is negative 3 times 2? Negative 6. Now I'm going to take my next term, negative 3, because that's what it's telling me, times the previous term, which is, the next term. So what is negative 3 times 3? Not 3. Look at me. Times negative 6, previous term. I said it right and you wrote the wrong thing. Sorry. So that's positive 18. Then I take the negative 3 times the previous term. And what is negative 3 times 18? Negative 54. So A is the answer. But you would make this table. It tells you where to start. And then you multiply, because it says -3, multiply it to the previous term. -3 times 2, -3 times 6, -3 times 18, and you would keep going. That's how I determine that it's A and not B. Okay, questions? All right, now let's look at number 3. Here we go. Problem number 3. Bless you. A geometric sequence is represented by the recursive formula. So here's the recursive. It says A sub 1 is 5 and A sub n minus 1 times 7. This is my recursive formula. What it wants to do is write the explicit formula from that. Okay? Well, the explicit formula, A sub n equals A sub 1 times the common ratio raised to the n minus 1. That is the formula for the explicit rule. Okay? It says geometric, so I know I need the little r and not the d. Okay? So now I'm just going to take that information and substitute it in. So I wind up with A sub n equals, what is my A sub 1? 5 times the common ratio, which is, and if you don't even remember, it has to be the other number, right? Because you know that this is the A sub 1, so that's not, so it's got to be that, raised to the n minus 1. And that's how that fits in. Okay? So, that is a review over those sequences. Okay? Geometric sequences and arithmetic sequences. Once you look at the rest of your packet there, the arithmetic sequence is given to you on problem 16. You still have to be given the A sub 1. And then A sub n equals A sub n minus 1 plus D. Okay? Remember here we're adding the D. Okay? So arithmetic means we're adding that. Okay? So keep that in mind. Any questions? Okay?